Let's discuss about projection of one vector over the another. Okay, so now we are looking at projection. Now, whenever we talk about projection of one vector over the another, let's do a simple thing. Okay, let's assume that we have a line, some line. Let's say this line is L. Okay, on top of this particular line, let's say we have some vector like this. Say this is O, this is A. All right. Now, what we are looking at, we are looking at one vector which is at some angle with respect to the line L. A line L is the horizontal line, correct? Let's say this is angle theta. Now, whenever we talk about projection, see projecting in the sense what? One, or the shadow of the one over the another. Like whenever say you're walking in front of a street lamp or a street light or whatever it is. When you're walking in front of it, what you're going to have? You're going to have a shadow behind. Now imagine that the street light is behind you. You are going to have a shadow in front of you, correct? That means you're projecting a shadow in front of you. When you say project, that shadow of one over the another. This is the meaning of word projection, correct? Now in this case, we are looking at projection of one vector over another vector. Now in this case, see if you look at this particular vector OA, the shadow or the projection is going to be like this. Okay, so this basically is the projection of vector. Let's assume that this particular vector is A. Okay, so this is the projection of vector A on the line L. On the line L, correct? This is why the projection, whenever we talk about projection, it's always on some other line or some other vector. Fair enough? So, if we have to understand this, in a little bit of mathematical sense, instead of line L, we look at vector B. In the sense, what we look at it, that is same thing. Instead of line L, say this is OB, say this is vector B, say this is OA, which is vector A. Now, what we are looking at? We are looking at projection of vector A on vector B. Okay, that means here we look at A is here, you drop a perpendicular like this. Okay, say this point is C. Assume this is C. Say this value is theta. Now what we are looking at is projection of a vector A on vector B is nothing but OC, correct? That's OC. But what I want you to understand is that OC and OB, they are collinear vectors, correct? Since they're collinear, their direction is one and the same, correct? Since the direction is same, direction of vector B. See, vector B can be written as what? Vector B is equal to mod of B into B cap. Here direction is given by what? Its direction is given by B cap, isn't it? So here the direction of vector B, or you can say direction of OB and OC, both the cases, the direction is nothing but B cap itself, correct? So we can say OC direction is B cap. This much we understood now. So what we got, that vector A is projecting on OB here, or you can say that vector A is projecting over B cap, correct? So the projection of vector A on vector B is going to become vector A into B cap. Vector A dot B cap, because projecting of which vector? Vector A on which vector? Vector B. But since vector B has a particular direction, take an example of the street light which is behind you and you're walking. Now street light is behind you, correct? Now the light comes and hits you. You are projecting a shadow on the ground. When you project a shadow on the ground, now here the ground is nothing but vector B. You are nothing but vector A, correct? Since you are projecting the shadow on B, the direction of the shadow is on the ground. That means the direction of the shadow is nothing but it's in the direction of the ground. Correct? See, when I say direction of the ground, like straight, basically, that is what I'm talking about. So, what is the projection of you on the ground? The direction in which you are going into the direction what you have. Correct? The vector, that is you, dot the direction in which it is going. The shadow is going. So, vector A dot B cap. That gives you the projection of A on B. So, this particular formula gives us the projection of vector A on vector B. Clear? So, same way, if you look at this example, vector A is being projected on line L. So, this is going to become vector A dot L cap. Dot L cap. Okay, now let's understand the mathematical formula for this one. What we have is vector A dot B cap. This is the projection, correct? And what is B cap now? Vector A dot vector B divided by mod of vector B, correct? Mod of vector B. So what do we get now? We can say that projection of vector A on vector B is equal to vector A dot vector B divided by mod of vector B. Mod of vector B. In the sense here, suppose if vector A and vector B are in the same direction, that is if theta is equal to 0 degree, then it's nothing but same thing. What I mean by the same thing is vector A and vector B are one and the same. Okay, like take an example. Say this is vector B. Okay, assume that this is vector A. Alright. Now what we do, this is angle theta. Assume that theta is equal to 0 degree. Now what do we get? A and B are one and the same, right? Now apply that over the formula. What do we have? A dot B is nothing but mod of A into mod of B, correct? Divided by mod of B, cancel. That's nothing but A. So this projection is nothing but vector A and vector B are one and the same if theta is equal to 0 degree. Okay. Now, if theta becomes 90 degree, then there is no projection. Think about it. If the sun is right above your head, you don't have any shadow. Shadow is your projection. There is no shadow whatsoever. Correct? And next is, if you lie down on the ground, then your shadow length and your length are one and the same. That's why in the 0 degree case, in this particular case, we got it as vector A itself. Like your vector A and your projection is your shadow, correct? When you lie down on the ground, your shadow and you are one and the same length. But if the sun is right above you, there is no shadow. That's why when theta is 90 degree, there is no projection of vector A on vector B. Okay. Now, suppose if theta becomes 180 degree, okay, then the projection is on the opposite side. Like assume that the light is in front of you, so the shadow will be behind you. Clear? So these are the three cases what we have. The projection where you have no projection at all, and how we are going to understand the projection. Clear? The formula for the projection is given by this. This is projection. Okay. Suppose if they say projection of B on A, same thing, A dot B by mod of A, that's all. On whichever vector you have, that comes in the denominator. Clear? So this is about projection of one vector over another vector.